No.
Okay, group meeting quiz.
Here we go.
Mhm. Okay, so question. I already opened this because I thought you guys were already working on the stuff, but
Okay. We have to round everything to 3 decimal places
Yep.
unless specified.
Okay.
Okay.
For the first one, I got. I want you guys. Have you guys done it too?
I haven't yet. Let's see.
so is the combined area under the standard normal cube that is right to C and left to C minus, right? So it will be the two on the sides. Am I right or
Yes.
wrong?
You're right.
I
So-
got 0.175.
Me too.
Yeah, I got 1.745, which is 1.75. I mean 0.1.
0.175, right?
Yeah.
Yes.
75. Okay. Yeah. Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Which will have a small standard.
What was that?
Mm.
Okay.
Oh, there's something if it gets smaller than something else. Let's see.
I think it will be the
Is it the middle? Let me see
I
here.
think let's see, because when you only have one, even though there's 9, the
Mhm.
distribution of the one will just be the standard deviation. And then of the sample means will be the standard deviation divided by the square root of 9. So
Let's see.
yeah, I think it'd be the sample means.
So the distribution of the sample means?
Yeah.
I'm sure I wrote this down somewhere. Let's see.
I'm having a hard time remembering what all the different symbols mean.
Oh yeah.
So what's the difference between the X and the X with the line over it?
I can't remember that.
Well, so X is individual observations, and X with a line is distribution of sample means, right? Isn't that what they're just saying that that's what it means?
I don't know. I think that's what they're trying to say in this one. Usually a line means something different, but it means something different in everything, so.
So the larger the sample size decreases the standard deviation, but does that even help us here? Let's see.
Mhm. Let me see. Because I was actually reading that. Okay, let me see. Last class. Okay, so it says okay, it says the sampling distribution what is the distribution of sample means? It says the sample distribution of the sample mean is the set of all possible values of thing over x that could occur. You have several example of sampling distributions, you have plotted many means in the simulations and observed the approximately normal distribution that occurs. In the real world, you only observe your sample mean. You do not get to view the distribution. However, the fact that you sample randomly means that you could easily have drawn a different sample and had a different sample mean, which is the sample mean is the little x with a thing with a line above. There are many possible sample means. You can think about your sample mean as a sample of size 1 from the distribution of all possible sample means that could have occurred. Is that what you guys were looking for?
I don't know. Let's see.
Are you guys still on 4?
Yes. No, I'm 3.
3.
No, we did 3.
Oh
right?
no, I'm 4. I'm 4. Yeah, you're right. I'm 4. Sorry.
Yeah, no, I'm pretty sure it's the distribution of sample means.
Distribution of sample means. Yeah, that's what I just read. So it's not the answer.
So did what you just read agree with the middle one? Are you reading in lesson 7 reading?
No, I'm reading lesson 6.
Oh, you're reading lesson 6.
Yeah.
Okay.
Okay, it says.
Okay. All right. Let's see.
Okay, it says mean and standard deviations of. Are you guys reading lesson 7 or 6? So I think the answer might be on lesson 6, but I might be wrong.
I'm looking in 6 right now.
Okay, because I found mean and standard deviation of the distribution of sample means. And it says the following facts are always true. They do not depend on the central limit theorem. They do not depend on the sample size. These facts hold for the sample mean of any simple random sample of size n drawn from a population with mean and standard deviation. The mean of the sample means is the mean, and the standard deviation of the sample means is the standard deviation divided by the sample size to the square root. It says the mean of the sample means was always aligned with the mean. Also, if you took samples larger than 1, the standard deviation of sample means was always smaller. What's going on? Was always smaller than the standard deviation.
Hey, Pappy, can I talk to you later? Can I talk to you later?
Was someone just trying to call?
I'm going to talk to you later.
I'm
Yeah.
in
In the middle of the group.
Oh, maybe it was Tiffany, whatever her name is.
Yeah, I'm trying to see, but I can't see. She should just be able to click in. Should we, you want to just keep going? If we can talk about that in a little bit?
Sure.
Or we can just click on the distribution and see what happens.
Distribution of the sample means?
Yeah.
Okay.
I don't know something that says that that supports that. I can't find anything that, but
Okay.
I'm guessing. I would guess that too. I just don't know.
Mhm. Bye.
Do you guys want to do number 5 or do you want to stay on 4?
Um, I don't care.
Okay, let's go to 5. Is
Which
this
is
a central limit theorem? Is my guess. I don't know.
For 5, I think it's the law of large numbers.
Oh,
That's
really?
that's what I was gonna guess too, but
Well, I'm looking at my lesson 6 prep assignment, and it's almost the exact same definition of the law of large numbers that was in the answers to it.
Okay. So can we go back and open those answers of like, because I hated that I tried to go back and I cannot see anything.
You can't see in the quiz or what?
Yeah, like let's say we're done and then I come back. I try to come back tomorrow and I cannot see anything.
Oh, yeah, I know. I don't know.
Yeah, so because that's what I liked about the I learned too, that you could always go back.
Mm.
Um, let's see. What number on lesson 6?
It was the prep assignment, and it was number 5.
Oh,
If the
okay.
sample size is large, the x will be approximately normal. With a lot large number states sample mean will be close. Sample mean x will be close to u, more and more accurate. I don't see how that. What does that say?
For
Oh my
number
god.
5? For number 5?
Yeah, number 5. So you're saying it's law of large numbers, right?
Yeah, so the central limit theorem is that if it's a large sample size, the sample mean is going to be approximately normal. Like it's going to be like the shape of it is going to be normal.
Hold on. Sorry. Can you say that one more time? My husband just came in. Sorry.
That's
As
fine.
the okay. Well, okay. So the spread in the what's the thing over x represent again?
That doesn't mean.
I don't know. Usually when X has a line over it, doesn't it mean oh, I can't remember.
That sample mean?
That's the sample mean, exactly.
Okay,
Yeah.
sample mean is
Yeah, because the U is the mean. The U is the mean. Or the thing that looks like a U.
so that's okay. So it's saying the spread in the sample mean decreases as the sample size increases. Spread in okay, I think that, yeah, I think part of that is, yeah, I think it is the large numbers.
Okay.
Because
Okay.
I wrote, if the sample size is large, then the sample mean will be close to the population mean. So that means that's what it's saying, right?
Mm-hmm.
Oh, this is making my brain hurt. Okay. Okay, so we're good on 5?
Somebody just sent something.
yeah, that was me.
Oh, that was you?
I found a page that has a list of different
Yeah.
statistic symbols,
Mm-hmm.
and so I just thought I'd pass the link along. That
Yeah.
the
So
X
X
with
with
the
the
line
line
over
over
it does
it.
mean sample mean.
Yeah. It also stands for the average. So
Okay.
that's what I was saying. I know I'd seen it before.
It stands for average.
Yeah.
Mm,
In like general math problems, it stands for the average.
okay. All right. So is the low large numbers the answer? The final
But
answer?
don't we want? Gosh, I don't know. Okay, I guess, yeah.
Come on, spit it out.
I think it's the way it's phrased is like throwing me off.
For 5?
Yeah. I
Yeah,
don't
yeah,
know
yeah.
why.
It is. It is because okay. Listen, Becca. It says which of the following results implies that the spread in X decreases as the sample size increases. And
Well, the
here
thing is,
in the law of large numbers says like as the sample size increases, the standard deviation of the sample mean will get smaller.
As sample size increases, the sample mean closer to population. Does that mean it's decreasing? If it's closer to the
I
Yeah,
think so.
yeah,
I don't
it
know.
will get smaller. It says.
closer
Yeah.
to mean is the same
Yeah,
thing as decreasing?
I saw something somewhere where the law of large numbers definition talk it's about accuracy.
Yeah, I remember that. That's why I'm like,
So
I
if
don't see how that applies here though, the accuracy. But well, I guess the spread
because
is more
the
accurate.
sample mean decreases, so that would be more accurate.
Yeah, you're right. Okay. Yeah, that makes more sense now. Not that I'm right, but that makes more sense to me.
I don't know if I'm right. That's just the logic I'm using.
No, I think you're right. Okay. So number 6, or you wanna keep
Number
going?
6.
See. Let's see. Z-score.
Okay, says.
Oh, Stephanie was trying to call, it looks like.
Oh, who is
Uh,
that? Is that the TA?
yeah.
Yes.
Trying to think how I can, I'll try calling her again. Let's see. It always lets her email. I don't know why it's not in here. SK.
So the answer will be value.
Then she can tell us the answer. Okay, I sent her a thing. Okay.
So it will be 160 minus 158.
150.8.
Yeah, you're right. Minus 150.8 equals.
1.046.
Let me see.
Z-score.
Yeah. I think it's 1.045.
Doesn't it? Oh, I had.
It keeps going 4, 5, 4, 5, 4, 5. So it would be the 4 that's trying to round up.
No, I just had 1.0455. Did you do 9.2 over or divided by 8.8?
I did 160 minus 150.8. And then I just took that fraction and divided it by 8.8, which was 1.0454545.
Oh yeah, my phone is different than this online one. Okay, that's weird.
Wait, guys, what's the population number for?
Just the 1.
Oh, 1?
Yeah, because it's just her score.
Oh, so it would be 8, like it would be 9.2 divided by 8.8.
No. So for the standard deviation, is that what you're trying to find out?
For number 6.
For number 6, yeah. So the standard deviation, you don't have to do the square root of the population because the square root of 1 is 1. So it doesn't really matter in this problem.
Okay. So it will be 9.8.
8.8.
Yeah, so it will be like 9.2 divided by 8.8, right?
Yeah. 9.2 divided by 8.8.
It's a 1.045.
Yeah.
45.
Yeah.
1.045.
Yes.
Yeah.
Okay. What was the number on this question? You said 9 point something.
9.2.
Okay, how did you get that?
It's 160 minus 150.8. So her score minus the mean.
Okay, so to get a z-score, you do x, and so x would be 160
Yeah.
minus the backwards y, which would be 150.8
Right.
divided by 8.8.
Yep. So we just need to put that score into the applet, right? To get the
Yeah.
5 to get. So the next question is probability that a randomly selected student will score above 160.
So we type the 1.045 on the little thing, on the probability pamphlet.
Yeah.
Yeah.
1.045.
On the z-score?
Yes.
Yeah.
Yeah, you put that z-score into the normal probability applet.
Mm-hmm. Okay.
And then we shade just the top to the right, right? Because we want above. So I got 0.148.
Yeah.
So it will be so to the right or to the left?
To the left.
To
to the right.
To the right, because we want the score above 160. Is that right?
Yes, I guess. Yes. So it would be 0.1480 or 8.
Yeah.
0.148. Yeah.
So I think somebody's trying to log in or something. Hello?
Sorry.
Oh, there they are. I was like, where are you guys? Okay.
Did she leave a message? I don't see that she's calling again. I see that we missed her call. Okay, number 8. Did you guys do that one? Let's see. We got the z-score corresponding to the sample mean of these students.
Yeah, and I found the mean of their 5 scores, and it was 160. And that's as far as I've gotten so far.
160 is the mean. So
we've
we
already
need
found the score. Well, not really, actually, but.
So is the mean same as the sample mean, right? We're trying to find the z-score corresponding to the sample mean.
Yeah, so the sample is of the 5 students. So those scores are the sample, and we want to find the mean. So I found the mean, and it was 160. Okay.
So we would to get to the C score, we will have to use the formula.
Well, what
Yeah.
do we? So what do we have to? So we want. So what
So
is
it
the
will
other value that we use?
be 160.
So 160 is the score that we're using, and so we're using the same mean, but the standard deviation this time is
Oh.
8.8 divided by the square root of 5.
Oh, I see. We're still using the information for it. Okay.
Yeah.
Okay. So 160 minus 1. Oh no, we just did.
Yeah, 160 minus 160.
Oh, but we have to do are we supposed to do the square root of?
Yeah, the square root of 5.
Okay, and then 8.8 over that, right?
Okay.
Okay. I get it.
So we would do 160
Mm-hmm.
minus 5.
No, minus 160.
No,
Minus 150.8.
Oh,
just
one,
like the last one.
one,
Absolutely the same.
150.8. Oh, yeah, you're right. You're right.
Yeah.
So it will be 9.2 divided by.
Why is it 160 minus 150.8?
Because it wants the sample mean of the 5 students' scores. So if you find the mean, it's 160.
Right, so that's the first number.
Yeah. And
Okay.
so then the second number, the 150.8, is the mean of everything.
The mean.
The mean. So it's the average of all the other student scores besides these 5, or including these 5 random students.
So I think I got
Oh,
2.3377.
That's what I got too. So
I
it'd be
forgot we were still
2.338.
using that information from above number 6.
Yeah.
Yeah, that's what I
Okay.
thought.
Okay, that's what was throwing me off. So we do 160 minus 150.8. Let me see if I can do one question here before you guys give the answer.
Okay.
Okay, so we got 9.2, correct?
Yes.
Yes.
Okay, then let me see. So then we would divide that by 8.8. Is that correct?
You have
No.
the standard deviation will now be 8.8 divided by the square root of 5.
It's that other one that you use with the sample mean, right? The distribution sample. Where you do the standard deviation divided by the square root of n.
Yeah.
Does that make sense?
What is the score? Can you say that again, please?
So it'll be 8.8 divided by the square root of 5 because 5 is n because there's 5 numbers. You do that one when it's the standard deviation of the distribution of sample mean, right? Am I right?
Yes.
Yeah.
Mhm.
I'm trying to explain it clearly.
Okay, so we do 8.8 divided by 2.236,068. So
You know what, guys? I think Stephanie wants us to join her call or something.
Is she talking to us?
I haven't seen anything.
I got a couple.
No, I see her here. She's typing something now. Okay, what is that? Beeping.
Okay, so for number 8, did you get 3.934?
No.
I got 2.338.
That's
Wait,
what I got too.
Yeah, me too.
You have the right number. You may have just.
338.
So it comes out, yeah, it comes out to 9.2 divided by 3.935. And that should equal the final. Because 8.8 divided by the square root of 5 should be 3.95. Okay. Does that make sense, Joel?
No, but that's all right. I'll
What?
figure it out later. We need to hurry.
Okay.
Becky, you need to be out by 6, right?
Well, no, I'm okay. I'm not doing the other one tonight because I have to go somewhere in a little bit, but we're okay. If you want, we can go over it again if you want while we're here. I
Well,
think
if
you
you
really
guys
the right numbers. You just did the math wrong, I'm guessing, because sometimes with all the square root and dividing it can get weird.
Yeah.
Yeah, what I usually do is like I use the saving thing on my phone where you can save the number instead of like you're writing the number down, because that sometimes throws off the whole thing.
What I do is I write it out, but I keep it in like fraction and radical form. But with my fraction on the bottom, I flip it so it's multiplying it against like the 9.2 instead of dividing it, and then I just enter it in my calculator that way.
Whoa, that's confusing.
I just save the number. And that's it. I don't. I'm more like I try to do it.
Do you have an iPhone?
Me? Yeah.
Joel?
Yeah.
Because when I put it in my calculator on the phone, I just do it like for the bottom part, 8.8 divided by 5, and then I hit square root and equal, and I think I hit equal twice, and then it usually gives me the right answer. I don't know if that makes sense.
Yeah, that makes sense.
8.8 divided by 5 square root. So then when you hit square root, it gives you the square root, and then you hit equals, and then it goes to 3.935, which is what I have to divide 9.2 into. So then that should be.
Okay.
Okay. So we'll move on to 9.
Okay. So the probability that 5 randomly selected students will have a mean score that's greater than the mean achieved by the students in the previous problem. So it's 5 to n. Is n equals 5?
Mhm.
Greater than the mean, so greater than...
So you take the z-score that you got an 8 and you put it in the applet, and then you only select the right corner because that's everything that's above that z-score.
Do we not have to do anything with 5 though? So n equals 5?
No, because we already did all of the work. In problem 8, we did all of the work.
Okay. Yeah, I get it.
So it will be 1.045?
No.
Oh, it will be
So you entered in the z-score 2.338,
Oh, yeah.
Yes.
and did you get 0.0097?
Yes.
oh, wait. Well, yeah, you're right. 2, I forgot to put that number.
Yeah, I think that's right because they want us to round it to 4 spaces.
Yeah, I know.
So what did you
So I
guys
was
get?
like,
So yeah, 0.0097.
Oh, yes.
Okay, good. So 10, let's see. They're asking about the shape of the sampling distribution of the random variable x, which represents a sample mean of the 81 students who are selected. So it's left skewed, but there's 81, right? So it's over, so it should be
Approximately normal.
yeah,
yeah.
because it's such a high sample. Right? Yeah.
Yep. What is the mean of the distribution of the sample?
So the mean is given to us, and it was 3.5.
$3.5?
Yeah, because in the information that it gives you,
Yep. 3.5, the
says-
standard deviation is 0.7. Mm-hmm.
See,
Okay, but that says, oh wait, oh I see, never mind, sorry.
the wording that is used in this course just really throws me for a loop. The mean
It
of
does.
the distribution of sample mean sample distribution for all possible samples.
Yeah, you just kind of gotta know what means what, and then after a while, it'll just seem normal.
Maybe.
Yeah, it'll start seeming normal around mid-July.
Around finals. Yep.
Yeah. Okay, so 3.5. The last one? Oh no, we had 2. Oh, we're doing a bunch more? Oh man. Okay,
Yeah, we got 15.
12.
So number 12?
Yeah.
So the standard, so we have to do that same thing, right? We have to do the standard so we have to do, what's the number?
It was 0.7 divided by the square root of 81, which is just 9.
Oh yeah.
So it will be 0.7 divided by 9?
Yeah.
0.77777.
Yeah.
So it was 0.0.
778. I mean 078.
Oh, it's 3, right? 3 decimals. Yeah, 78. Yeah.
Yeah. 0.078. Okay. So the probability that the mean GPA for 81 will be less than 3.3.
So do we have to find the the C value or C score?
Yeah, you have to find the z-score, and then we'll put it into the applet.
3.3 minus 3.5 divided by the 0.078. Is that right? Because we already found that.
So it was like, you said 3.5 minus,
So X would be 81, correct?
no, that would be
No, that's n.
N. 81 is a population. So what are the numbers that we need to use, guys? So it said that you said 3.5 minus what? 0.7?
So the 3.3 minus 3.5 is the top of the equation now. And then we're just going to divide it by the standard deviation that we found in problem 12.
But what is 3.3 from?
That's the
3.3
GPA, correct?
is the GPA that we are finding the probability of.
Less than. That's in question 13.
Okay, and then
okay.
so
So
you
it
said
would be minus,
I'm sorry, Carlos, go ahead.
I was going to say 3.5 minus 3.3 or 3.3 minus 3.5.
3.3 minus 3.5.
Okay.
3.5 is the mean.
Oh, yeah. Divided by,
So negative 0.2
mhm.
divided by 0.078.
Yep.
Yeah.
So negative 2.564.
What did you negative 2.564? Is that what you
Yeah.
got? Yeah, that's what I got.
Wait up. Minus 2.564.
Yep.
So we type this on the answer or on the graph?
Yeah, so you put the negative 2.564 in the applet, and then we shade to the left, right? Because it's we're looking for less than 3.3. That's what I did.
So that I don't have to wash that every day. But I don't have to wash that every
So
day.
the answer would be 0.052.
Zeros. Wait.
I think it's going. They just want us to do
0.005, right?
3 decimals, so 0.005.
0.00. Okay.
I'm gonna put all this in the closet.
So then the next one is just asking for greater, the same thing, right? So we just need to shade the right side.
No, you'd need to shade the middle too, because it's anything greater than the.
Shoot.
So it would be
Well, it's greater than
0.995.
3.3. The middle wouldn't be 3.3, would it? Doesn't it have to be on the...
So on the probability applet, for 12, what, 12, right? No, 13. It was the left corner because it was anything less than what we got.
Oh,
But since it's greater than it's everything else.
okay.
So 0.995.
Okay, yeah. Alright, fine. Okay.
I didn't mark yet. This equal 1 though. we're supposed to have 3 decimal places. Top to right is correct. I read the lesson today. I know what I'm doing. No, but I did the homework. Hang on, take over the top part.
Okay, so what is the formula that we have to use? Do we have to use the one from this chapter?
For 15? From 15, right?
Yeah, for the last one.
So find the probability that a random sample of passengers will have a weight is as extreme or more extreme that was observed in this sample. Means we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive. So does that mean like the left and the right side?
I think so.
Yeah, I think so.
So do we have to find a z-score and then plug that in?
I believe so.
They already, let's see, they gave us a sample.
So, walk me through how you would determine what numbers are x, the backwards y, and the o with the tail.
Okay. So when you read it, you see the words the standard deviation is, and so that'd be the O, I believe.
Yeah.
So that's 26.7 for this one. And
Okay.
then you'll keep reading, and it says, and the next sentence is the random sample of 48 passengers were recorded. That'd be N. So N equals 48 for this one. And then the next sentence, it says the sample mean was determined to be 177.6. And so that'd be the little Y thingy.
Yeah. Okay.
Does that make sense?
Yes, it does. Thank you. So would we?
So are we supposed to plug in just 177.6 minus 185 and find the z-score with that? Like,
Yes, I think so.
so then we did this 26.7 divided by the square root of 48. Is that right? Is that what you guys are doing?
Yes.
Okay.
48. Wait, say that again, Becca.
So for the bottom, so you're doing 177.6 minus 185 for the top. And then below you're doing 26.7, which is the standard deviation, divided by the square root of 48, which is n.
No, Rogue.
And then you have to solve.
No.
I get minus 1.921. Well, 92
9201.
or like 92.02.
Yeah, that's what I got.
That's for the answer? Or
No, that's the z-score.
wait, what was it again?
Negative 1.9202.
Yeah, I got that too.
Okay, so we want extreme or more extreme, whatever that means.
So the left and right?
Well, except for the left is right next to it. So I don't understand
Okay,
The
let me
left is
see.
right next to what?
where the z-score is.
They just said they want the furthest away. I don't know.
It says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean than was observed in the sample.
So it wants everything, so it's 1.
Well, it says above or below.
Yeah.
It says as extreme or more
Oh, it says
extreme means
either. So it'd be above?
And below. Right?
either above or below the mean, yeah. Mhm.
Or is it one or the other? Are they both the same?
I don't know.
And then
Oh gosh.
it says note.
Well,
Either
okay.
it says either above or below. So maybe we just need to do one side. You know what I
Yeah.
mean? Because they're both going to be
And
the same, right?
yeah, both of the sides are going to be the same.
So it's 0.0274. Is that what you got? Or
Yeah.
Yeah, I just wonder if we need to add anything to that, like if we need to have the middle and that, or that and then the left side added to that. I don't know. But that seems extreme because it's the furthest away from the z-score that we had.
it says no, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours. So that's what it's like. Do they want both or do they not want both? Do they just want one?
I don't know.
It's a confusing question.
I
Yeah,
think it's the right and the left. Because interested in values that are lower and also values that are
above.
far away.
Yeah,
Okay.
that kind of makes sense.
So it'd
So
be
it'd be
point-
0.549 or
Yeah.
0.55.
If we
Yeah.
miss it, we could try the other thing. I think it would be right. It's either going to be one or the other, I think.
pretty
Or
much.
both of them together. So I think
So
if we go back.
0.055.
Yeah.
Yeah,
Yeah.
probably. Hopefully.
Can I give a spoiler alert?
Sure.
What?
We got 100.
Woo!
We did? Wait, I didn't say 5. Or so 4 we did do the distribution. Yeah. Why didn't I save that? Nice. We got 100?
Yeah.
Okay. Let's see.
Okay, sample responses.
well, let
No
me
stuff.
rephrase that.
What
You'll
happened?
get 100 if you completed the individual preparation assignment.
Or said
I
you
didn't
did.
do that, so I didn't get 100. But everything else was right.
Okay. Should I stop this? Are we good then?
Yeah.
Yeah.
Okay. Stop recording.